So this should look familiar. This is our star formula chart, and I'm going to show you a couple of useful things that we're going to be using or have already learned in this upcoming unit. So the section is linear equations. It's the very first one, so it must be important. So linear equations is the topic unit that we are now into, and what you'll notice is that we have been working with this one I'm highlighting in yellow here, the y equals kx. And we've learned that k equals the constant of proportionality and when you put the constant of proportionality in relation to y and x, it creates a direct variation. So this is the formula for a line, but only when the line is proportional, meaning that it passes directly through the origin at some point. So maybe I'll use red. So if it passes through the origin at some point, let me draw that a little better, work with me here. So that would be your line if it went directly through the origin, and it can be positive, it can be negative, as long as it is a straight line that passes through the origin. So unfortunately, we don't always have proportional relationships, and so that's where our next friend named y equals mx plus b comes in, and this is broken up into what we call slope-intercept form. So our x and y, just like in the direct variation formula, the x and y, so the y and the x, still just represent any coordinate, just like you plotted yesterday on that paper. They still represent any point on the line. And then we have m here that represents slope when it's non-proportional. And then we have this here, b, that represents something called the y-intercept. Okay? And we're going to talk about more in depth about both of those things, just pointing them out right now. Don't ask me why they didn't label slope with an S rather than an M, or why constant of proportionality is a K. I just don't know. These are just questions I do not know. So this is a formula for a line that is, let me just use a different color, any line that does not pass through the origin, that's a straight line. So remember, it has to be a straight line. Okay, so now we're going to hop into our notes for this section right here. So yesterday you watched the concept of slope dude, or you watched the video, and what I'm going to do is sketch the concept that he talked about. So what we're going to do is he goes skiing, and he's going up the mountain, and he's working hard, so he's saying puff, puff, positive here, so that is a positive slope. And then he gets to the top and he goes down and he says, nice, negative. Okay, that's our negative slope. And then he gets to this point, that's a straight line, and if you've ever been skiing or snowboarding, you know that straight lines when on skis or a snowboard is zero fun. So 0 is our slope, that is a horizontal line. And then our drop-off slope, which would be a vertical line up and down, is our undefined slope. Okay, so we have the 4 different types, positive, negative, 0, and undefined. And those are the types of slopes that we can see. But what we're going to talk about is different things that can mean slope. Just like sometimes we have nicknames, alternate names for the same thing, slope is not immune to that. So rate of change is one way to say slope, and some place that you might see that is something like miles per hour. a rate of change, miles per hour. A unit rate, like thinking about a rate per unit. Example, if you buy a dozen eggs and you pay $3 for them, there's 12 eggs in a dozen, so how many eggs for one egg per carton? Maybe something like that, eggs per carton. M, just like we talked about from the formula chart, this literally just means slope. I don't know why they didn't use S. K we know is our constant of proportionality. And rise over run is a way that we determine slope specifically when looking at graphs. And we're going to talk, that's going to be like our main focus on these notes, is using the rise over run method, I guess. So the first thing that we're asked to do is to identify the slopes as positive, negative, 0, or undefined. So I'm going to scroll past my slope dude here so I can zoom in on one of the examples, but you know that you have them in front of you still. So we need to determine if it's the puff puff positive, the nice negative, the 0, or undefined. So something I like to do, and maybe this doesn't help you, so forget if it doesn't help you. I'm going to kind of just extend the points of the graph. So I know that that was my slope dude, positive, negative, 0, and undefined. So I know that it's this one. I just kind of redrew the slope dude, and then I identified it right from the beginning. Okay, so it's a negative. Number 2, again, I can just redraw the slope dude thing. Puff, puff, positive, nice, negative here. Oh, and then I see this is my 0 fun part. There we go. Okay, and again, you don't have to do this every time. I just think that it's good visual representation. I kind of just draw the whole thing. So positive, negative, 0, undefined. So I see, oh, there's my positive. Oh, negative is the one I'm looking for. So we have our puff, puff, positive. See, that one with the positives, it's already there. It's the first one we find, positive slope. This one again is our positive. So sometimes it gets a little more tricky when they become more steep or less steep. So we see that that's the positive one. And this last one here, we can look at our last one, and this is the undefined portion. The undefined slope. So those are our examples. Again, you do not have to draw the extension of the line. I just think sometimes it can be helpful to see the visual of slope dude. He's a memorable guy. And now that we've identified whether lines are positive, negative, we need to know what the actual slope is, because saying a slope is positive or negative, 0, or undefined is not an adequate, because just like in our formula that we looked at in our here, the slope, if we're not just going to be able to just put a plus or a minus there, a 0 or an undefined. So we're going to actually have to find a number to go along with it. So these are the kind of keys to success when finding the slope using a graph. So I'm going to just go ahead and read them. You're going to use 2 points on the graph, and I emphasized pretty points because that is, let me just review a second for pretty points. So on this one here, if you see these two blue dots here, these are what we consider pretty points. So if you notice, pretty points here. So if I just were to draw a dot right here, you see how this dot is not, like, it wouldn't be easy to give me a coordinate pair. Whereas on this pretty point right here, this point here, it would be super easy to say, oh, the location of this one is 2, -1. Whereas this point here, again, it's still on the graph, but it's not a pretty point because it would have decimals, like we would have to say 1, 2, 3, maybe 3.5 up to 1.73 or 1.25. So this is not a pretty point. The pretty points are the ones that intersect. So if we just took this point right here and we moved it, so you see how that's a pretty point, that one obviously, this one. So there's more than, so that would be our other pretty point on the graph, okay? So we want to make sure we identify pretty points. Let me go back. Okay, so identify pretty points. You may have to make your own if they are not already pointed out, just like I did on this graph. This one was not marked out. These two are already there. Then we're going to start at the left point and draw a rise, which may be a fall until you reach the next level, reach the level of the next point. And then you're going to draw a horizontal line to the right until you reach the next point. Count to make a ratio of rise over run. Be sure to watch the interval of the graph. If it's not labeled, you can assume they are counting by ones and then simplify. So let's do a couple examples together. So it said to start, I'm going to erase these. It said to start at the left point. So this is my furthest left. And I'm going to count up. Let's use pink. I'm going to rise. So I'm going to go up 1, 1, 2, 3. So I went up 3, so that's going to be my rise number. And then I'm going to run 1, 2. So here we see my rise, my run, and this is an overall positive slope. It's going to be a positive slope, and that, my friends, is the final answer because 3 over 2 cannot be simplified. And I know that some of you are going to want to turn this into a decimal, but if we turn this number to 1.5, it makes it harder for us to graph it on the graph since it's separated by rise over run. Again, I know that I said decimals are easier for me, but in the instance of using a graph to find slope or graphing slope of a line on a coordinate plane, you're always going to want to stick with the fraction, okay? Always the fraction. All right, this next one, number 2. So we see here that this is a negative slope right from the beginning. And so we're going to start from our left point. We're going to start from our left point here. And remember how in that directions it said it might be a rise and it might be a fall, but it's still the up or down movement. You're rising or falling. So we're going to start with our left point here. And in this case, we are going to fall. So let's go 1, 2, 3, 4, 5. So that's going to be our rise, 5. And then our run is going to be 1, 2, 3, 4. So again, this is our rise. We're going to keep it, I'm still going to write rise even though it was a fall, over run, 4. And this was a negative slope, so that, my friends, is what our rise over run is going to be. And I'm just going to show you really quick. I know that it says rise. We could have still risen on the other side. I could have gone now from this point here. I could have done 1, 2, 3, 4, 5. I could have done 5 on this side and then run 1, 2, 3, 4. I could have done that as well. It doesn't matter. I'm going to try and be consistent by starting with that left point and then counting down and across. So rise over run. number 3. This is also, we see here, this would be a positive, and then it would be a negative slope overall. So we need to make sure our final answer is negative. And I'm going to again start with my left, for this left point here. And it looks like it's going to again be a fall, which is a rise. So it's a 1, 2. So this is a 2 of a rise. And then we're going to run 1, 2, 3, 4, 5. So this is a rise of 2 and a run of 5. And this is a negative overall. And that is our answer. Negative 2 over 5 is our slope. Okay. Number 4. This is a positive slope. So our answer is going to be a positive. So I'm going to start now with my most left point. And then I'm going to rise 1, 2, 3, 4. My rise is 4. And my run is 1. So rise 4, run 1. And it's a positive, but 4 divided by 1 is just 4, so that is going to be our final answer. And so that's when they're talking about simplifying. 4 over 1 is not wrong, it's just you're always going to see slope in the answer choices. It's going to almost always be in its most simple fraction. So you don't want to think you got it wrong just because you didn't simplify. Okay. Number 5. So if we were to redraw slope, dude, positive, puff, puff, positive, nice, negative, and then we get to our 0 fun slope. So this slope is just 0. We don't even have to count from point to point because we can't rise. We can't rise, and 0 divided by our rise was 0 and our run was 1, but anything 0 divided by 1 is just 0. Okay, and our last one, number 6, is our, so remember, this is going to be our undefined slope. That is because if you're wondering why it's undefined, so our rise, so say we went from here to here, our rise would be 1, but our run would be 0, and anything divided by 0 is, if you maybe take a second, type in 0 on your calculator, 1 divided by 0, you're going to get something that says error, because anything divided by 0 it's what they call undefined. All right, so those are our 4 examples. So what you're going to do is go to the paper from yesterday, the one that I had you graph all those points and draw the line, and now you're going to take your new knowledge and you're going to find the slope of those 12 problems. So I'm going to do the first one right here. So beautifully done by me. So I have on my line, I have already identified that it's a positive slope, and I've already plotted my points properly. And so what I'm going to do is take my points and find my rise over run. So I'm going to start with my furthest left point. I'm going to redo it in pink. I'm going to do a rise. So I went a rise 1, 2. So a rise 2 and a run 1, 2. So what you notice here, 2 divided by 2 is just, so your m, or your slope, is just going to be 1, okay? So I want to just show you, erase these ones really quick. So what if I wanted to go from this point here, this negative 4, 0, and I wanted to go up 1, 2, 3, 4, 5, 6. I was just trying to make my life hard. If I went up 6, my rise was 6, and then I went 1, 2, 3, 4, 5, 6, 6 over 6. So I still reduce to 1. So it doesn't matter, as long as you're going from pretty point to pretty point, you'll still end with the same answer as long as you simplify the fraction properly. So technically, I could have had points on all of these. These are all pretty points. My line isn't perfectly straight, but you can see that there. So that's what you're going to do for these, and make sure, like just on number 2, you make sure that you put in your answer, so m equals 1, make sure that you're putting your positive or negative in your answer. So if it's positive, you don't have to write anything. If it's negative, you're going to write negative.